Hi, my name's David. I'm going to be going over even, odd, or neither types of that style of function. A function is considered even, odd, or neither. There's a graphical implication that's very key, and I'll try to tie that in. On the algebra side, the simple test is for an even function is if you plug in an x value and you substitute, if you plug in negative x and substitute in negative x wherever you see it, it basically disappears. It comes out identical to what the function looked like to begin with. When you have an even function, this is going to give you y symmetry in the equation, because every time you plug in a negative, it acts the same as a positive. Forgive the sound of the rain coming down right now, sorry. So if I took negative x and I threw it into, let's say, x squared. Let's throw it in to the idea that the function is just to simply square the input. Well, I put the negative in there. And look what happens. Negative times negative becomes positive. Negative x times negative x is positive x squared. So it stayed identical to the original rule. And if you don't remember, it's a good idea to have the parabola, just main idea of a parabola, one of the parent functions in your head, it does have y symmetry. Anytime I plug in an x value over on the right, like positive 2, I'm going to get an identical output on the left when I plug and chug a negative 2. The rule for odd functions is also similar. You plug in a negative x and see what happens. So here is the rule. If you plug in a negative x into a function that is an odd function, then what happens is the negative suddenly kind of appears on the outside in front of the whole function. And it becomes the exact opposite, or in the sense of graphing, a flip of that idea. Odd functions are something like a typical odd function could be x cubed. So if my function is simply 2 cubed, if f of x is x cubed, and I want to test whether it's an odd function, then I'm going to plug in a negative x into it. The instruction is to cube whatever the input is. The input's negative x, so I throw it in. If you have negative x times negative x times negative x, try to visualize that. Negative x times negative x times negative x, that's cubed. You get 3 negatives, 3 x's multiplied, so you get negative x cubed. Do you see how this is simply the negative of the function, just like the rule says? So that's what an odd one is. Now, the graph of x cubed looks a little bit like that John Travolta dance move I always say. Okay, so that's what an odd function looks like. To understand the idea of plugging in the negative graphing-wise, okay, by the way, this is called origin symmetry, sorry. Origin symmetry, I should have said that. Origin symmetry. It means it was reflected both across the y and the x. So both reflected across the y and the x. And so what it means to be an odd function in terms of negative and positive input. So let's say I put in a positive 2 input and the graph would take me up there and I'd have that y value. Well, at negative 2, you have the exact y value, but negative. And that's what it means. You have the exact same output, f of x, but negative. And that's how we connect these ideas. Let's just try a couple of these problems. Let's try, 34 looks interesting. 34, and maybe let's do 38. Let's just try 2 of these. So the algebraic test is to plug and chug a negative. The algebraic test is to plug and chug a negative. So I just throw the negative x in, negative x specifically, and I'm going to simplify. I'm going to simplify very carefully. Mind those order of operations. If I have 4 negative x's multiplied, that's 4 negatives, that's positive, and that's x to the 4th. So this becomes x to the 4th. There's still the 2 on the outside, so I just bring the 2 down. Okay, now we're going to go negative x squared. Negative x squared is negative x times negative x. So this becomes a positive x squared, but there's still a negative on the outside. So you want to bring the negative down. Now, if you look at this equation, this is the same as their starting point, f of x. Therefore, I say this is even. I also know that whatever this graph looks like, and I don't personally know what a quartic looks like in this one, but I know it's even. I know it's even. Okay? So that means I know it's y symmetry. So I know it's going to be a graph, and I'll give you an idea what possibly this graph could look like. A lot of these will look like this. Okay? Whoops, I tried to draw that perfectly symmetrical across the y-axis. So at this moment, I'm trying to mirror it, trying to reflect it. That's y symmetry. Oh, I didn't reflect it well. Let me try that again. Okay, that's better. Not bad. This is a typical quartic graph. We'll talk about them another time. And you don't have to know this. Pop it into Desmos. I really recommend popping these into Desmos and making sure that you can make sense of them. So this is an even function. It's not odd, and it wasn't neither. We'll talk about that in a second. 38. If I plug in 38, if I plug in negative x into the function, I'm going to get negative inside. Well, I'm stuck. I can't do anything with that. I'm dead in the water. You cannot take a square root of a negative in a real world, in a real graphing system. There's the imaginary one. Don't go there yet. Okay, so that means I cannot simplify this. It is not, this is what I'm checking for, it is not identical to f of x. No, I couldn't get back to it, couldn't simplify it. And it definitely can't take the negative out of a square root. There's no algebra move for that. So neither one of these happen. I did not get equal to the same. I did not get equal to the opposite of it. So that didn't happen. That means I have a neither, which means this graph is not origin symmetry, and it's not y symmetry. And if you don't remember, here's your rational graph. There's your rational graph, or excuse me, radical graph. I said that wrong. That's the graph of y equals square root of x. So if you look at that, yeah, there is no y symmetry, and there is no origin symmetry. Origin symmetry means it would have a reflection over and a reflection then under to be that graph. So there is no graph doing that on that side. So it is not origin at all. I hope this helps.